All right, let's talk about the Wronskian of functions. All right, so Wronskian is a very nice tool to determine if a collection of functions are linearly independent or linearly dependent. All right, so let's look at the definition of Wronskians. Let's say if you want to look at the Wronskian of function, say f1, f2, and all the way to, say, fn. Right, and this is defined to be the determinant. Right, then first row is going to be those functions, so f1, f2, and so on, and fn. Right, second row would be its derivatives, so f1 prime, f2 prime, and so on, and fn prime. Then the third row would be second derivative. So you just keep on taking a derivative, second derivative. Right? And the last row would be, let's see, so that's going to be the nth row. So we take the n minus first derivative. Right? Then, so the last row would be just the n minus first derivative of all these functions. Right? Alright, so this is the definition of Wronskians. Then, if they are not identically equal to 0, then we know that if this is the case, then we know that f1, f2, and so on, fn are linearly independent. If this is identically equal to 0, then functions are linearly dependent. Alright, so let's look at a simple example. So example would be, say, we can try function 1 and also maybe x and maybe e to the x or something like that. Right? So the Wronskian of those three functions, I'm not gonna list that. So what we have to do is first you list 1x e to the x. Right, second row will be a derivative, which is 0 and 1 and still e to the x. Right, last one would be 0, derivative 1 would be 0, derivative is still e to the x. Right, so in order to find the determinant, I'm going to expand along the first column. So it's going to be 1 times. Right, submatrix would be, so strike out this row and this column. So you have 1 e to the x, 0 e to the x. Right? So this is going to be e to the x minus 0, so it's going to be just e to the x. Right? So you can see that this is not equal to 0, which means that these guys are linearly independent. Alright, so that's how we use Wronskians to determine the collection of functions are linearly independent or linearly dependent. So the Wronskian is not equal to 0, then it's linearly independent. If the Wronskian is equal to 0, then they are linearly dependent. Right? That's it. I hope that this was clear.